This one? That probably isn't a star. It's probably might be a satellite or might even be a comet actually. Because this time lapse would be over such a long period of time that a comet would make the most sense. Or it might be a geostationary satellite, actually. So, okay. Geostationary satellite would stay in the same spot, but it could move up and down a little bit. Yeah, so it would move perpendicular to the rest of the stars. Okay, good question, Oliver. All right, so we've got a bunch to cover today. Are we ready? Okay. So I want you to all take a moment and consider your address. Okay, I want you to take into account your address, right? I could find out all of your addresses. I'm not going to because, you know, information, whatever. I'm just going to make one up. How about 4830 Washington Boulevard, Ogden, Utah, 84401. Okay? We usually end there, right? We usually end there. Well, in my opinion, well, not in my opinion, that is enough for our, you know, whatever system we might be using. But if we're mailing outside of the country, from outside of the country, so when I lived in Brazil, I would send letters, and I would have to put the address and then EUA, which is Estados Unidos de América, which is the United States of America in Portuguese, right? So the EUA, the United States of America, right, USA, is a country. And that is as far as we need to specify, at least for our purposes for humanity, right? So I'm just gonna make a text box here. I don't remember what it was. It was 4832 or 38 or whatever. Washington Boulevard, ELBD, Ogden, Utah. Oh, that's not correct. Utah. There we go. 844-84401. Or I guess we could do the address of the school, which is 2033 Grant Avenue, right? Well, we need to keep on going with this address.
Oh no. You ever watched the movie
Oh? No, I have not. USA, United States of America. So if we are to zoom out, what is the next thing on our address? What? North America. North America. North America. Oh. America. Okay. Now what? So third planet from the sun, huh?
Yeah.
So we were.
Third planet from Sol.
So we call it Earth, right? The astronomical classification for our planet is Sol D.
Sol.
Sol.
I mean, you could do northern hemisphere.
No. We're not going to do hemispheres. We could do coordinates on the planet. You're right, we could. But we give names to everything. Okay, Sol D. Why Sol D? No, Nate, what were you going to say? Right, so the star, so you're referencing a system when you say a star name. Our star's name is Sol, okay? Sol A is the star. Sol B is Mercury. Sol C is Venus, and Sol D is the Earth. So you move out using letters for the planets, okay? And we all know what Earth looks like, right? There's the classic, let's see here. Where is the blue marble? Oh, there it is. Let me pull it up just a second. Wait, where'd it go? Oh, I lost it. There it is. This is the classic image here of the Earth. The blue marble. Blue marble. This image actually was taken in the other orientation, in what you would call an upside down orientation. This is Africa here. And this image was taken, I think, by Apollo 16 command module pilot. Who was the Apollo 16 command module pilot? I don't remember. Harrison, maybe? Anyway, so this picture was taken, and the original is actually flipped upside down. Antarctica is on the top of the, anyway. But this is the classic image here. There are many other real images that we have of the Earth. This is a real image of the Earth. This is also a real image of the Earth being photobombed by the moon. How rude. I think that this is also a real image, but this is a false color image. They increase the saturation of some of the colors. Okay, pretty cool. You gotta love how red Australia is. That would be a sweet marble. That would be a sweet marble. So, got a donut Earth there. Donut Earth. So all of these, most of these are just artist renderings or like pictures from Google Earth. Not all of these are real images, obviously, especially not that one. Okay, so we live on Earth.
Especially not that one that has it in somebody's name.
Yes. All right, so Earth's name is Sol D. Okay. Where do we go from here?
2 turns left.
2 turns left. We need to specifically this. If we say Sol D, it is a little bit redundant, but we can say the Sol system. Okay, which is of course our solar system. Okay. Now, if we were to zoom farther out, what would we say?
Milky Way.
So we are in the Orion spur of the Milky Way. Okay, the Orion spur in the
Which arm?
I'm trying to remember the name of the arm that we're in. It's not Sagittarius.
They probably wouldn't. If there was like aliens or anything, they wouldn't know the name of the arm, really.
No, they wouldn't. But if we had like if we had a galactic federation, we would all use different names probably for like different places, right? Using the native language. But anyway, the Orion spur. I'm trying to remember the Milky Way arms. I don't remember which arm we're in. We are in one of them. Yes, no, that's not what I wanted. That's not what I wanted.
You just become an exoplanet.
We are in the Sagittarius arm. So we are on the Orion spur of the Sagittarius arm. Orion spur. Sagittarius. That's my best guess. Sagittarius arm. Okay? And then we get to the Milky Way. Are we done?
No,
No, we are not.
of course we're not.
Very fascinating information over there, Trent and Ramses. Yeah, fascinating stuff. Okay. So the Milky Way is part of, and prepare to be shocked. Remember that astronomers are not very good at giving creative names to things. We are in the local group. The local galactic group. Okay? So when we so the local group, I probably need to specify galactic. I don't want like pictures of people at a barbecue. Okay, this is the local galactic group. This is the Milky Way here. And this is the Andromeda galaxy. Okay. And we have these other little orbiting galaxies. So the Milky Way and the Andromeda galaxy are the two major galaxies in the local group. There are galaxies orbiting galaxies, yes. We have two small galaxies that orbit us very close, the Small and Large Magellanic Cloud. The Sagittarius dwarf is like not really a full galaxy. It's just kind of a string of stars. But the Small and Magellanic Clouds, in the southern hemisphere, if you look up toward the southern celestial pole, you'll see two fuzzy patches. They are the Magellanic Clouds. They are two tiny galaxies that orbit the Milky Way. Okay, pretty sweet. And then we have the Sculptor dwarf, the Fornax dwarf, Carina dwarf, Ursa Major and the Sextans dwarf, Ursa Major 2 dwarf, okay, all of these different dwarf galaxies. And then Andromeda has its own dwarf galaxies that orbit it. These two are on a collision course. Andromeda and the Milky Way are moving toward each other at several 100,000 kilometers per second. So it's pretty fast. I think they're moving at several tens of thousands of kilometers per second. I think it's like 10% the speed of light. They're moving it toward each other. They'll run into each other in a while, a couple billion years, to make Milkomeda or Milkdromeda. I'm pretty sure it's Milkdromeda. Yes, again, not very creative names.
Universal ship names.
Okay, so that is the local galactic group. Yeah, somewhere. Life will be around somewhere. And I'm pretty positive that it will be Earth-derived life. Okay? Please tell me that I'm recording. Please? Okay, we're good. All right. So the local group, after the local group, we get to the Virgo cluster. Keep on zooming out here. Okay, these are some in, give me a map. I want a map. Because we are inside the Virgo cluster. There we go. So we're at the center here in the local group. The Virgo cluster, like the large part of it is here, but technically we are all, oh, sorry, the Virgo super cluster. They call it, anyway. This is a whole bunch of galaxies all close together here. Well, close together in quotation marks. We're talking about hundreds of millions of light years between each of these galaxies. This spans, so you can see this is tens of millions of light, or 10 million light years here. So I think that this is the full span of this is something like 100,000 or 100 million light years. Okay, pretty amazing. And we have all these different clusters of galaxies. Okay. For reference, the Milky Way galaxy is 100,000 light years across. We are about 30,000 light years away from the center of the Milky Way galaxy. And the distance to Andromeda, I think, is something like, what is it? It's like 400,000, no, more than that. Let me think about it. It's like 2 million light years, something like that. I don't remember. It's a few million light years. Okay, so that's the Virgo cluster. We're almost there. I'm going to try to spell this right. Laniakea. I think that's the way you spell it. Don't put it down in your notes until I put it in the search. So it'll super cluster. Okay. Laniakea. I'm pretty sure I just spelled it differently there, but whatever.
And purge.
So these are all artist renditions because, again, we are inside of this. Okay. Big most. So the local group is right here. Okay, so we are here. The size of this, do we have a scale? We do not. The size of this is something like 1 billion light years across. All of these are galaxies, okay? That's how you spell it. What? Oh no, it froze. There we go. All right, and this is as far as we go until we get to the observable universe. Why do I specify observable universe? Oliver? Are things outside of that moving farther than the speed of, moving faster than the speed of light? Yes. So there is what we call the cosmic horizon. The cosmic horizon is due to the fact that the universe is expanding, and the farther away you are from something, the faster it is moving away from you. Because every point of space is expanding. So, and if you have more points of space between you and it, you have more expanding things. So everything that is very far away from you is traveling away from you faster and faster. And there's a certain point at which these objects are so far away from us that they are expanding away faster than the speed of light. Okay? Nothing can move through space faster than the speed of light, but space itself can expand faster than the space of light, the speed of light. Okay? And what happens is that there becomes a situation where there has not been enough time in the universe for these objects to be seen by us. There has not been enough time for the light to get to us. The farthest objects that we can see are about 12 billion light years away, because the universe is only 14 billion years old. And as they expand away from us, they will slip over the cosmic horizon. In future generations, and when I say future generations, I mean like millions of years, humanity will look up from whatever planet we inhabit at that time and see fewer galaxies in our telescopes because they have slipped over the cosmic horizon. So while the universe expands, we actually see less and less of it. Okay? So the observable universe is everything that we can see. We do not know for sure what is beyond that cosmic horizon. We can safely assume that there is more universe. In the observable universe, we see a few things. So we have our star, right? Sol. Sol is one star of about 100 billion. Is that billion? Thousand, million, billion, yeah. In the Milky Way. Okay? Okay? The sun is one star of approximately 100 billion in the Milky Way. The Milky Way is a pretty average galaxy. Not huge, not tiny, pretty average. The Andromeda Galaxy has about 10 times more stars than we have in our galaxy, with around 1 trillion stars. There are approximately, as far as we understand, around 1 trillion galaxies in the universe. In the observable universe. If you multiply 100 billion, which is a safe estimate for an average star count in a galaxy, by 1 trillion, you get something like 1 times 10 to, I think it's the 28, which is a pretty close estimate to the number of grains of sand on Earth. Okay? That's a lot of stars. Yeah. Quickly. Class ends 10:55, so we have 45 minutes left. Yep, 45 minutes left. Okay. Questions on this? So our cosmic address is this. Earth, Sol System, Orion Spur, Sagittarius Arm, Milky Way, Local Group, Virgo Cluster, Laniakea Supercluster, Observable Universe. We are on one of 8 planets that goes around one star that is in a galaxy of 100 billion stars, and in one galaxy of approximately 1 trillion galaxies. All right? We're not even on like a very large planet. If you take all of the mass in our solar system and you look at it where it is in relation to other stuff, so the percentage of mass in certain things in the solar system, the sun is 99.99% of the mass of the solar system. Jupiter is the other 0.01%. Everything else is essentially negligible. The Earth is less than 1/1000th of the mass of the solar system. Okay? No, less than 1/1000th of a percent. Okay, of the solar system. It's pretty crazy. All right? Pretty crazy. We are very small. And I'm going to show you a picture. Oh, I don't want to get rid of that actually. This is a very important picture. This is what is called the pale blue dot. This is an image taken by the Voyager 2 spacecraft as it was passing by Neptune. After it passed Neptune, it turned around and it took a picture. And this dot is Earth. A single pixel. This streak of light is actually a lens flare from the sun. I think that Carl Sagan, who was the person that said that we should take this picture, and he was one of the key scientists on the Voyager program, I think that he said it best, that we are a mote of dust suspended in a sunbeam. This is everything you have ever known. This is all people. Everyone has lived and died and been loved and forgotten on this single pixel. Okay? And that picture is still within our solar system. If there was life, intelligent life on the closest stars to us, and they looked at our sun with the same kind of telescopes that we have, they would not detect us. They would not detect the Earth. They might be able to detect Jupiter, but they would not detect the Earth. We are in a very, very cold and inhospitable universe. We are very small. We are completely alone. However, the fact that we are able to say, this is where we live, the fact that we are able to send a piece of machinery tens of billions of kilometers away and turn around and take a picture of home, that is nothing short of miraculous. Truly incredible, okay? We'll talk about Voyager. We might talk about Voyager later. It's one of the most inspiring missions in human history. My shoulder tattoo, the pulsar map, is to commemorate the Voyager program. It is amazing, okay? So, that's our cosmic address. Any questions on where we are in the universe? You feel insignificant yet? Good. You and your problems, everything that we've ever felt, everything that we've experienced, goes on without the universe having a single thought about it. The universe is much larger, much more grandiose than our small problems. And I hope that doesn't depress you. I actually hope that that helps you to see the world as it is and to give you perspective of don't sweat the small stuff. Okay? Don't sweat the small stuff. Because there's probably life on a planet that's being blown up by the supernova of its host star right now. Like literally right now. Okay? So you getting your bag of chips stuck in the vending machine, I think is small potatoes in comparison to this planet that has literally been wiped out by the supernova of its host star. Okay? Yay! All right, thumbs up, everybody. Okay, speaking of supernova, we need to talk about some stuff really fast. I'm going to end this recording.